Go.
Hi, today we're going to show you how to remove and replace the sensor and also how to calibrate an SM95. I'm showing you this diagram. On the right you'll see the pencil sketch of what I made, what the sensor looks like. Right next to that, to the left, you'll see the sensor itself with the bead in between, and this is the D pin, just like it shows in the drawing over here. This is also an example of what the socket looks like. The sensor plugs into this socket. The D pin is indicated by the red line on the side. There's also labels on the front face of this blue socket. The back side of the sensor looks like this. There's the serial number label. For each sensor, it has its own serial number. The serial number label side is the part that gets plugged into the socket. You do not want to plug the bead into the socket. You'll smash the bead. It'll ruin the sensor. So to show you how to actually take the sensor out of it, to the SM95. Before you remove the sensor, you want to make sure you remove the power. Remove the power from the sensor by disconnecting it. I'm going to disconnect it from the power supply that we have here. So you can also make sure that it's disconnected by measuring it at the terminal block. This is the terminal block coming from the power supply. You put the red probe on the red wire. The black one on the black one is the two outside ones, pin 1 and 3. You'll see that there's no voltage there. If I plug it back in, when it's plugged in, you'll see there's 24 volts. That's normal. 24 volts is what it runs on. So we're going to remove the power again. Once you remove the power, you can safely remove the rain shield, what's known as the F44. By unscrewing it, pulling it straight out, you'll see the sensor is then exposed. Before you unplug an old sensor to replace a new one, you want to locate the D pin. You can locate the D pin by either looking at the white ring, or you can find the red line on the side of the socket. Once you've located that, you just go ahead, grab the sensor. You can rock it back and forth a little bit, pull it straight out. It's in there quite snug. Don't be afraid to pull on it. Then you grab the new sensor. You locate the D pin. I look for the white ring. You find the D hole. You plug the sensor straight in with the bead side facing you. Put the F44 back on, the rain shield. Reapply the power to the sensor. You can come over here to this terminal block. This terminal block is where you measure the heater voltage. These wires come from the sensor socket over here. You measure across pins 1 and 3 to see what the heater setting is. The heater setting on this one in this case is about 1.1 volts. And if you leave the red one on the red and put the center one on the center, this is going to give your collector voltage. It's going to be roughly 7 volts, maybe a little less, maybe a little more, right around 7 volts. When we apply gas, this voltage will drop. I'm going to show you where the adjustment potentiometers are located. I'm going to turn it this way a little bit because the labels are this way. If you remove this green cap, you'll see a red cap and a green cap. Remove this green cap. Under there will be the heater potentiometer. The label for it is right there. On this side is the 0 potentiometer. It says it right here on the board. And here is the span potentiometer right here. So once you've located those, you want to make sure, like I said, you want to make sure the heater is set properly by measuring here and adjusting this potentiometer if necessary to whatever it says on the bag that you received the new sensor. At that time, we're going to measure the output at TP1 and TP2, these two test point sockets. These sockets will hold the probes from the voltmeter in there by itself. It should be 0.10 volts, 0.10 volts at 0. You can see that slightly above that. I'm going to use this screwdriver to turn this potentiometer slightly down till I get 0.1 volts approximately. 0.102, 101 is fine. We really want 0.1 volts. So at this time, I'll show you how to mix the calibration gas. We'll come back for calibration. Okay, at this time I'm going to show you how to calibrate the sensor using the calibration canister. It has the top on it with a rubber septum that fits over the rain shield of the SM95. You want to go ahead and put the canister over the rain shield. We've got our voltmeter probes measuring the output of the transmitter. You're going to need the syringe to get the gas out of the pure gas sample that we're going to use to calibrate. You're also going to need a screwdriver to turn the potentiometer to make your adjustment. So this time we're going to show you how to take the gas out of the bottle. You want to make sure to keep your finger over the plunger before you put the needle into the bottle. Because if you don't, there's pressure inside this bottle. It's going to push this plunger up, and if your finger's not on it, it's going to push it all the way out. The gas is going to escape out of the bottle, and you're going to lose all your gas. So make sure your finger's over the plunger before you put it in. And also make sure that your needle is snugly pressed onto the end of the syringe. Go ahead and push it into the bottle and allow the gas to come in by letting your finger push the plunger back. Now what we want to do is we want 200 ppm, so we want 0.2 cc's. This full syringe is 1 cc, we want 0.2. So let it come back beyond 0.3 because we're going to inject from 0.3 to 0.1 into the canister. So let it go beyond 0.3. Make sure you put your fingers on the needle and help the needle come out of the bottle instead of just pulling on the syringe so it doesn't get separated, because if that happens again, you'll lose the gas from the bottle. So pull the needle out, and we're going to go ahead and just push the plunger down to exactly 0.3, letting the excess gas escape out of the needle. Then we're going to take the needle, we're going to push it through the rubber septum of the calibration canister, push it through there, and we're going to carefully push from 0.3 to 0.1, inject that gas into the canister, and go ahead and pull the needle out, dump the remaining gas into the air, and watch the output when it starts to read. With ammonia, there is a lag before it will start to read the gas. That's normal. Some gases read almost immediately. Ammonia does not. It will take some time for it to start to respond to the ammonia. Just go ahead and keep your eye on the voltmeter. At first it'll be a slow response. As you can see, it's starting to respond to it. It will start to get a little faster as it responds more and more to the ammonia. This could take 1 to 2 minutes to actually get a stabilized condition for this sensor, for this gas at 200 ppm. Higher concentrations definitely read better. They read faster. As you can see by looking at the voltmeter, it's starting to go up. It's continuing to go up. It's responding to the gas pretty well, actually. So once we reach a stabilized condition, when I say stabilized, it might tick very slowly. It keeps going, 0.001, 0.002. That's not stabilized. It'll slow down much slower than that once it becomes a stabilized reading. Once it does become a stabilized reading, you're going to use your screwdriver with the flathead side. You're going to locate the span potentiometer over here, and you're going to turn this span potentiometer whichever way necessary to be at 0.4 volts. 0.4 volts is a full scale reading. As you can see, we're not quite there yet. It's slowing down considerably. I would still let it go beyond this, but for the sake of not having such a long video, I'm just going to go ahead and show you that you can take your screwdriver, put on the potentiometer, and slowly turn it up to 0.4 volts. 0.4 volts. is a full scale reading. Once you have 0.4, you can go a little bit below that. You can see that it's going to go ahead and keep ticking up. Go to 0.4. If it's very slow like that, or even slower than that, you can consider that a stabilized reading. I'm going to go ahead and take this off just for this training video. I would still let it tick up like that and adjust it down, adjust it down. It could take a couple of minutes. But once you remove the gas, you should be able to see the reading begin to come down. The reading will continue to come down like that. It could take up to 15 minutes for it to read 0 again. 0 output would be 0.1 volts like we started with. As you can see, it comes down fairly slow, especially with ammonia at this concentration. But that is how you calibrate a sensor. You would do that to each one of these sensors, just like that.